Good morning, afternoon, whatever it is, friends. It's Mr. Reed. And yes, there's two new things happening right now for today's lesson. Number one, I'm in bed just like most of you are, probably for most of the day. So I figured why not just stay here in bed. Let's do a little bit of learning in bed. That's okay. Learning can happen anywhere, no matter where we're at. So yeah, we are sitting on Mr. Reed's bed. Second thing you get to see in football, we'll talk about that a little bit. Second thing, the mustache is gone. The stash is gone, guys. New time for us to just learn again. I'm super excited. I even got a hat on. I'm repping my school, Arkansas State. Go Red Wolves. Anyways, let's get down to the nitty-gritty of business today. Yesterday, we talked about what? States of matter, right? So we talked about states of matter yesterday. Can you name those three states of matter? Go. Yes, you nailed them. Solid, liquid, and gas. So, with those three being a solid, liquid, and gas, and we talked about them yesterday and kind of gave some examples of them, I say we talk some more about their properties, okay? We didn't get into a lot of it yesterday. I say we get into the nitty-gritty of it today, and that means we dive deep. We jump into that pool head first, right? So let's get into it, okay? But we're going to start by reflecting a little bit, kind of going back to yesterday, kind of remembering what we talked about, kind of shifting through there, and then we'll talk about some new things. All right, so pretend I have a snowball here and water here. What would be the difference between these two? Maybe think about the way they look, the way they feel, the way they smell, even if they smell, the way what would we use to be able to describe these things? Our senses, right? We use our senses, and we use our senses to describe what types of properties? Physical properties, right? Things that we can see, things that we can observe, right? So water's different, right? How is it different? Water's different from a snowball. How? A snowball is a solid and a water is a liquid, right? And if the snowball can turn into liquid by doing what? Melting. And what can make it melt? Heat. Man, see, you can see how we've transitioned from 2 weeks ago. We talked about heat making things change all the way till now. See how science connects? It's super cool. If I take a snowball, it's going to be wet and cold. It'll melt right with my hands because my hands are warm. But if I take water and spill it, it's going to make a puddle, okay? And we see that these are different. But I want us to know that there are things that we can compare water to a snowball because they kind of are in the same family, because water can turn into a snowball and snow can turn into water. But we talked about that objects are made of things. And what did we say that everything is made up of yesterday? Matter. What's the matter with you, right? Matter is what makes up things. So for example, matter is anything that takes up space. We'll get back to the football here in a little bit, but this is matter. Now imagine if I took all the air out of this football. How would you think? Is air matter? Think about that for a second. Is air matter? Can you see air? Nope, you can't see air, right? So is it matter? How do we know air is matter? We'll think about it. If I deflated this football, we could weigh it and it would be a certain weight. And do you think it would take up this much space? No, it wouldn't. But if I aired it up, if I pumped it up, it would weigh more. And as a matter of fact, you can see here, if I can find it, right here on this football, it says inflate to 11 to 13 pounds. Why would they tell me that? Because I can insert air and make it weigh more. It gives it mass. These physical properties, right? We use our senses to describe these physical properties of matter. Includes looking, tasting, smell even, hearing, and even touch, right? And so today we're going to dive into like 5 categories that we can use to classify these in between mass, which we just kind of talked about, flexibility. When have you ever heard of the word flexibility? Let me see if I have an example. Okay, look, I've got my toothbrush here. If I get my toothbrush, watch it bend. Ready? You see it bend? What is it? It's flexible, right? So flexibility, we have texture. I can touch this football, maybe smooth, a little bumpy if you have, see the leather, maybe a little bumpy, right? Texture, temperature, we'll dive into that in a little bit. This right here tells you the temperature of things. You can see right now in my room, it says that it is 78 degrees. It's pretty hot. I need to turn the air conditioner on. And last but not least, shape. Mr. Reed's favorite sport to play, golf, besides basketball. Y'all know I love basketball. A shape, okay? So these are the 5 categories that we're going to use to define matter, to define these properties, okay? So here we go. Let's review more properties of matter. Let's review first. Let's review shape. So shape, for example, objects have different shapes. So let's go to a share screen, why don't we? Let's go to post attendee here. Let's click on this. Now let's go here, and I want us to look at a if I can spell it right, P-Y-R, pyramid. Let's look at this pyramid. Now pyramid, images. Now pyramid almost looks like what flat shape? A triangle, right? A pyramid's actually shaped like a cone, right? A notebook can be a rectangular prism. My phone technically is a rectangular prism. It's a 3D shape, right? And so a golf ball, even, it's shaped like a sphere, right? And so in each piece of matter has a shape. As you can see here, the pyramid has a shape. It has definite shape, right? Let's look at another one. Let's look at, for example, Earth. So if you look at Earth, or even, how about we do this instead? A globe. Now we've all seen a globe before. A globe is what shape? It's a sphere, right? A sphere. And a sphere, it takes up shape as well, right? It's not just a circle, but it's an entire sphere, just like my golf ball, right? And then last but not least, I wonder if any of you have ever heard of this. This is called a Rubik's Cube, and I spelled it wrong up here, but a Rubik's Cube. You can see all different kind of shapes right here. But Rubik's Cubes are another example, right? All of these objects have a shape. All of this matter has a shape. Everything has a shape. Name something you can think of that has a shape. Now, once you've thought of it, is it matter? Absolutely. Now, you're probably thinking, Mr. Reed, well, air doesn't have shape. You're right. Air doesn't have shape on its own. Air actually fits the shape that it's in. Go back to my football. The air inside of it now has a shape, right? And it's shaped like my football. Therefore, air can also be matter, or like a balloon even, right? Now, let's look at mass. Now, mass is a little weird because we kind of hit on it yesterday. And if an object has enough mass, it's going to be heavy. Now, an object with little mass, it's going to be kind of light. You see what I'm saying? And we can measure mass using triple beams, scales, things like that. Now, I want you to think for a second. A balloon and a bowling ball can kind of have the same shape, right? They're kind of the same size even. Which has more mass, the balloon or the bowling ball? Now, if you're thinking what I'm thinking, you're like, Mr. Reed, that was maybe a kindergarten question. It's a bowling ball. Yes, it's a bowling ball. You're correct. The bowling ball has more mass. It has more mass than balloon. but it has nothing to do with the weight all the way. Weight, technically, like we talked about, is more with your gravitational pull towards Earth. And we won't get big into that, but there is a difference. Know that weight does not equal mass. Repeat after me. Weight does not equal mass. Weight does not equal mass. Now let's look at this. Some of you have seen this before. I like to call this a tape measure. A tape measure does what, friends? What does a tape measure do? A tape measure can like help us link things. So for example, I'm going to do the length of, oh, I covered you up. I apologize. I'm going to do the length of my computer, and it says it is 12 inches long. So I have a foot long computer screen that you are actually watching me from right now, right? So length can tell us how long something is. Matter has length. So for example, I take my toothbrush, I look at the length. We see my toothbrush is around 7.5 inches long, right? Matter has 3 things so far. It has shape, it has mass, and lastly, it has length. So on your piece of paper that you have right now, I want you to give me an example of all 3. Give me mass. Give me an example of something with mass. Give me an example of something with a shape. And give me an example of something with length. Those 3 objects. Go. All right. We're back. Let's talk about another one. Temperature. Now, this is a different type of temperature gauge that y'all are probably used to. This is not one that when I'm sick, I'm going to stick under my tongue. You can see it has a pointy end. This is actually for if Mr. Reed's cooking. Okay. If it's cooking, I want my food to get to the right temperature so I don't get sick. So I cook it to the right temp. So I turn it on and I stick it inside the meat, and it'll tell me how much I've got. But I've got some water here, and I'm going to prove how it works. You can see where it says 78 on it now, if you could read it. Here we go. I'm going to switch hands so y'all can see it better. See where it says 80 now? It's getting hotter in here. But as you can see, I put it in some warmer water, and you can see it's already getting to 95, 96 degrees. Maybe even all the way to 97. Let's see if it gets there. Come on. Oh, we were so close, right? But we could see matter. Water's also matter, by the way. Head to head. It's matter can be in all 3 states, not just solids. It can be solids, liquids, and gases. And we'll get back to that water in that cup here in a second. But temperature measures how cold or hot something is. Or for example, one of my favorite little treats to snack on. Super cold ice, right? All these different items matter. Yes, they matter, and they are matter. And they have temperature. When it feels cold, when it feels hot, temperature's measured using the thermometer. I showed you a thermometer for my food, right? It's recorded in degrees Celsius or Fahrenheit. We always look at it as Fahrenheit. What's the temperature today? See, watch. I'll ask Alexa. Hey, Alexa, what's the temperature today?
Right now, it's 62 degrees Fahrenheit. Tonight, expect a low of 59 degrees. Happy Wednesday.
Well, that was super kind of her. But we can see that temperature is also a part. The air is what gives us temperature. The sun gives us temperature, right? All of everything in the entire world is made up of matter. Now, that's kind of our reflection. Now, I want you to give me something with temperature as well. Give me an example of something with temperature, something that's hot, something that's cold. Go ahead, pause me, do it real quick. We're back. Okay, now you know the 3 states of matter. I'm not going to spend my time going over it. You know it. Okay, and we use the same example so many times to define the 3 different kinds. What are the three states of matter? Say them with me. Solid, liquid, gas. And we know that one of our best examples we can use to define all three is water. Water is a liquid, right? Excuse me. Water is a liquid, and so when we freeze it, it turns into ice, and then ice can be considered a solid. Now, if we go back to the water form and we put it on the stove and it starts to boil, what are we going to see come up top? What are we going to see rise from the water? Water vapor, and we consider that what? Gas, right? So, you know these three. You know the three states of matter. But there's two more things I want us to look at when it comes to matter. We've talked about shape. We've talked about size. We've talked about temperature. We've talked about length. Okay, we've talked about mass, how something weighs. There's two more that I want us to look at. We've kind of touched on it at the very beginning of the lesson. Texture and flexibility. Now, I want you to pre-think. Tell me, what do you know about flexibility and about texture? Go, write it down. Now, if you've written them down, you know, hopefully, and if not, you're about to learn, texture is the way that something feels, and we use our senses to develop, to understand, to see all these things, right? So texture is the way something feels. Okay. Sandpaper has a super rough texture, right? Glass has a super smooth texture, or my cup has a super smooth texture, right? Or the glass on my phone, super smooth texture, right? But if I take a rock, it may not be smooth. It may be jagged. It may be rocky. If I take this football, right, it's going to be a little bumpy because of the leather. Or even with my golf ball, you can see the little indentions inside. It's going to be smooth, but there's little bumps on there, right? And that helps it roll better when it's on the grass. Anyways, or my shirt, it's super soft. Or my golf ball. Guys, it's hard, right? Now, flexibility describes how something can bend, its ability to bend. So, for example, let's take my toothbrush. You can see it better right here. I can bend it. It has flexibility. Now, my football, if it's deflated and I did it on purpose, you can call me Tom Brady, right? I can move it in just a little bit, but I could try to bend it or take my TV remote. If I bend this TV remote, I ain't going to have a TV remote anymore, or even my phone at that matter. If I take my phone and try to bend it, that dude's going to break. That dude will break. So some things have flexibility. Flexible objects bend easier than something that's not flexible. They can even stay that way sometimes. Some objects even return to the original shape. For example, Play-Doh. If I bend Play-Doh, it's going to stay the way that I bent it, right? I don't have any Play-Doh, so I can't show you. I apologize. But that's the way it's going to be. But if I take this toothbrush, so you see, you can't, because I've got to buy a new toothbrush. But sorry, friends. But yeah, I've got to buy a new toothbrush. Anyways, most of the time, flexible things will go back to normal. Yeah. So let's look at my golf ball again. What would you say the texture of my golf ball is? It could be bumpy. Some of you may say smooth. That's the texture of my golf ball. Now, is my golf ball flexible? No, my golf ball is not flexible. I cannot bend it, and I'm not going to try to, or I'm going to end up with a broken toothbrush and a broken golf ball, right? So yeah. Now, there's also another thing we can look at two more, as a matter of fact, and then we'll end the lesson on that. But there's also volume. Now, if you've ever heard of volume, volume is how much space something takes up. And a perfect example is this measuring cup. Now, Miss Reed loves to cook, and I love to cook so much that I have that temperature gauge. But you can also see I've got this cup, and it helps me measure a certain amount of things. Now, we can use tools like graduated cylinders or measuring cups to measure a certain amount of things that we need. So, for example, if I can move it close enough, I know that as you can see, what is this on? It's on the number 200, right? So there's a volume amount of 200 milliliters inside of that of water. Everything has a volume. And you're thinking, Mr. Reed, okay, that's liquid. What about a solid? Well, perfect. Why don't I just show it to you right now? Let's take my golf ball, okay? You can see it's at 200, right? Or very close to 200. Okay, 200. Watch. Now let's look at the number. Now, if you're looking with me, you can see that it's almost moved all the way to 250. Did I add more water? No, all I did was add that golf ball, which proves to us what I could do is I could subtract how much I now have from what I originally had. What I originally had was what? 200. And now I have 250. 250 minus 200. Let's do that. As a matter of fact, let's share a screen. Let's go to whiteboard. 250 milliliters minus 200 milliliters equals what? 0 minus 0 is what, friends? 0. 5 minus 0 is what, friends? 5. So we have our ones place, our tens place, and now let's do our hundreds place. 2 minus 2 is 0. I need to leave it there. So I have 50 milliliters left over, which tells Mr. Reed that that golf ball's volume, amount of space that it takes up, is 50 milliliters. Right. Now, last we have hardness. Now, my favorite basketball player, James Harden. Okay, James Harden, fear the beard. He could stay with us for the rest of the video. See if I can keep him in here. He can just stay with us. James Harden, perfect. James Harden, yes, he's a human. He's made of matter. But his last name helps us because there's hardness. And in order to test something's hardness, scientists use a scale called the Mohs hardness scale to see how much hardness something has. The higher the number, the harder the material is. Now let's take a look at a video to show the hardness of different types of minerals, starting with talc all the way to the hardest mineral that there is. Let's see if I can share a screen. Go here. I would like to go to this. Here it is.
One of the factors used to identify minerals is their hardness, which means how well they resist being scratched by a harder mineral. So what we're going to do is go through and show you the steps that we would take to show hardness for the minerals. This is talc. This is listed as number 1 on your list. With talc, it's one of the softest minerals, and if you notice that even my fingernail will leave a scratch on it. This is number 2. It's called selenite. It is also a very soft mineral, and so we can also show that it will scratch with a fingernail. This is called calcite. It's number 3 on your list. This one we can try with a fingernail, but it really is too hard for my fingernail to leave a scratch. So for the next step, we would try a penny, which is made of copper, and we'll find that if we press hard enough, you see it leaves a scratch mark. Fluorite is going to be a little harder than the calcite. This time, the penny is not going to scratch it, but if we take the fluorite, we can scratch the penny. So you see the scratch?
Yes.
Right there.
Now I see it.
Okay.
Okay.
So that means that fluorite is harder than the copper. Then we can also, but we can find something that's harder than the fluorite. If we use a blade, a metal blade, we can actually then scratch the fluorite. So it takes this is going to be harder than the fluoride is.
Pretty cool, huh?
The blade scratches. Okay, we're getting a little bit harder. This is called apatite. This is number 5 on the list. We're going to find that the blade will also scratch it. Now this one's a little bit harder to see. The blade will scratch it, but it's harder. It's harder for me to scratch it with the blade. So that's because this is harder than the fluorite that we scratched before that was a little bit easier to scratch. So we're getting harder each time. This is number 6. It's called feldspar. This time, where we were able to scratch the others with the blade, this one is not going to scratch with the blade. If I press down, even pressing down on it, I can't get it to scratch. So that means this is harder than the blade. But if I take a piece of glass, the feldspar can scratch the glass. The blade is cutting it there.
Really well.
Okay, so the feldspar is harder than the piece of glass. This is number 7. It's quartz. And this one is also going to be harder than the glass, but it should scratch the glass a little bit easier because it is harder. Let's see if it does. Very definitely cuts through the glass much easier than the feldspar did. Where we had quartz before, this is number 8. This is topaz. So as the numbers get higher, we're getting harder. So now we're going to take the topaz and see that to prove that it's harder, it will scratch this quartz. But it's a little bit harder to get them to scratch as we get harder and harder. This one doesn't move. Okay, are we seeing anything?
Not really. Yeah, here it is.
Okay, right there. As we get harder, then they are harder. And so we're not going to get as easily a scratch as we did before. Number 8 again was the topaz. Number 9 is called corundum. Corundum is one of the hardest minerals that we have. And we're going to see that it does a pretty good job on scratching the topaz. See it?
There it goes.
So then the scratches right there. All right. Once again, 9 was corundum. Number 10, you'll notice that if you see anything if we look at the kit, it's going to say not in the kit for number 10. Number 10 is a diamond. This happens to be in my ring. The diamond is there. We talked about in class that diamonds are the hardest. Diamond, if I could get to the diamond, to the edge of it, it would scratch the corundum because diamond, again, is the hardest mineral that we have. Talk about in your group what can cut or what's going to be able to scratch the diamond. Think about it.
So friends, I know that was kind of a neat video. We're not in groups. We haven't talked about it in class, but what's neat is you can see the hardness of these different minerals can all scratch one another as they get harder and harder and harder. And all of matter also has hardness too, whether it's a solid, a liquid, or a gas. Liquids aren't hard at all. Air's not hard at all. Solids are what's usually hard, right? But each piece of matter now, not only does it have hardness, it has texture, it also has flexibility, right? Guys, I miss you. I'm going to look and see if that video, like you could hear it. If not, I will for sure post the link to it in my description so you can actually hear what she's saying. Miss you guys. Be safe. Next week, magnets. Be back, friends.